Right, let's look up. First of all, we plot the point 2, 9. So 2 and 2, 9, 2, and then we go up to 9. That's the point A. Then we plot the point B, which is 6, 1. Thank you. Yep. Put the brakes on it. Right, so there's line AB. Using only a compass and a straight edge, construct a perpendicular bisector of the line segment AB. Show all construction. Perpendicular bisector. So watch this. Just look up. Perpendicular bisector. So first of all, what you do, looking up, looking this way. You take the compass and you place it on one of the points. So we place it on point A. Right. So what you do is you extend the compass. There's roughly halfway. So extend it just a little bit further, about 3/4 when you're bisecting lines. Alright, now you keep hold of it and you swing an arc like that. Take the compass and with the same length, don't change the length of the compass, put it on B. Now with the same length on the compass, you swing another arc until those two lines cross each other. This point and this point is important. So line up this point and those 2 points, this one and this one, with a ruler, and then draw a straight line. That's a perpendicular. This line is perpendicular because it's at 90 degrees now. Bisector means it cuts AB in half. So this half is the same as this half, the same length. Right, you just keep looking up, we'll continue on with the question. Right, C is the point 10, 8. So I'll mark 10, 8 up as far as 8. It just happens to lie on that line, so we'll put a circle on it and we'll put C. Now it says find AC, so what I'll do, that makes a triangle out of it, so I'll join those. AC is the length of that line, and in the second part it asks me to find the length of BC, the length of that line. These are the type of questions you need to be studying. Right, from your papers, page 18, from your maths tables, there's the formula for the length of the line, right there. The length, it says length on the right hand side. The left hand side is Irish, FOD, length. So AC, so it's the square root of, now from your maths tables page 18, Rory, read out the formula. The length of the line formula.
x2
minus
x1
squared plus
y2 minus y1
squared. Alright, and we'll be finding the length of BC, so I'll write the formula over here as well. So same again, x2 minus x1 squared plus y2 minus y1 squared. Alright, A and C. So A, so we'll write down the points A. So A is 2, 9. And C is the point 10, 8. Right? And we mark the first point x1, y1, second point x2, y2. Over here, this will be the second part of the sum. We'll write down B and C first of all. B, 6, 1, and C, 10, 8. X1, Y1, X2, Y2. Right, up here we'll fill them in. So tell me, Oshin, X2. X2 is the first thing on the formula. It's 10. This minus X1
2
squared plus from the formula. bracket y2, keep going, write down the minus sign, and y1. Now believe me, at this point of the question you've already passed the question, more than passed it. But we need to finish it off. AC with these two lines mean the length of the line AC. So you keep tidying it up slowly. So 10 minus 2 is 8 squared, plus 8 minus 9 is minus 1. Use a calculator if you're not too sure. Right, the square root of, so 8 squared is 64. Minus 1 times minus 1, that's what that means, is plus 1 equals square root of 65 is the answer, if you add 64 and 61. So that's the left hand side, and now we do the right hand side, BC. So again, square root side, x2 is, let me see, Samir, you call them out quickly. So we're starting off here, x2 is 10, we've done that, minus x1. What? X1 is? Plus y2 from above is 8, then minus y1, 1 squared, yeah. So this is BC. So 10 minus 6 plus 8 minus 1. BC. So here is 4 squared, which is 4 by 4, which is 16, and 7 squared is 7 by 7, is 49, and that adds up to 65. So the right hand side, AC was the square root of 65 on the left hand side, and the line BC was the square root of 65. So if I bring it up here, AC, the length of that line is square root of 65, BC, the length of that line is, so the square root of 65 is an actual length, it's an actual number. So it's actually 8.062257. So it's an actual distance. Right, what do you think? Before we go any further, if a triangle has two sides that are equal in length, what do you call that triangle? What's the name for it? Isosceles. So it also means that these two angles here, that angle is the same as that angle. Right, we'll see what the next question is. What can you conclude about the triangle ABC? Give reason for your answer. So it's an isosceles triangle. And why? Because AC is equal to square root of 65 and BC is equal to the square root of 65. Those two lines are equal in length. Right, next bit. D is the point where the perpendicular bisector bisector of AB, there's the bisector of AB crosses. So this is the point D here. That's the point D. Explain why the triangles DAC and DBC are congruent. Explain why DAC, this triangle here, and DBC, this triangle here, are congruent. They're the same in every way. Well, so you have to, the two triangles must have three things in common for them to be congruent. Alright, so will you look up? Look it up. Look it up. Three things in common to be congruent, alright? So we know that this length AD is equal to DB, isn't it? Because we're after bisecting that line. That's one thing they have in common. What else do they have in common? They both share this side. They both have this side in common, don't they? So you say DC is equal to DC. So that's two things in common. And these two angles are in common. They're the same because it's an isosceles triangle. So that's three things they have in common. So if two triangles have three things in common, they're congruent. That means they're the same in every way. Alright? Do you understand that? So I'll just write it down. So the length of the line AD is equal to DB. So AD is equal to DB. Those two lines are the same because we bisected that line. We cut it in two. Right, DC is common to both triangles. So the way you write that down is you write DC is equal to DC, both triangles. And then you can say that angle A is the same as angle B because it's isosceles. So angle A is equal to angle B because it's an isosceles. That's the reason. Triangle. Three things in common. Therefore, the triangle on top, ADC, is congruent to DBC. It's the same in every way, and this is how you write it down. Triangle ADC is congruent. 3 strikes to triangle DBC. Same in every way. Right, do you want to take down that bit? That